Welcome back for this online class. First, I introduce myself. So, I am D. Vignesh, Assistant Professor, Department of Computer Science and Applications, Islamia College, Autonomous. So, this is your first unit. Before that, the title of the paper is Digital Logic, Fundamentals and Microprocessors. This is our core paper. So, there are 5 units are there. The first 4 units which is covered on digital logic fundamentals. Then last unit is microprocessor. For that core paper, it has one practical is there, that is digital logic fundamentals and microprocessors lab. So theory and lab is there. So totally 5 units in this paper. Myself take first unit for number system. So from that way, the digital logic fundamentals. Before, what is digital systems or digital computers? In a digital computer is a programmable machine that process binary data, that is data represented in binary number system. What is a digital computer? Is a programmable machine that process binary data only. So binary data means there are two values, one is 0, another one is 1, because in we have to understand computers and digital systems or digital electronics only with the help of binary number system. What is the system can understand only, the digital system can understand only with the help of binary number system. So that's why a digital computer is a programmable machine that is process only a binary data. So this is known as digital system. Okay, so this is our introduction for in a digital system. Okay, now go to next. So this is our outline of chapter 1. First, what is digital systems? I told you what is digital system. Okay, a digital system can understand only a binary numbers, that is a zeros or 1 or on off, or also called low and high. Low for 0, then high for 1. So this is known as digital system. Okay, then types of number systems. First, what is number system? Then types of number system: binary number system, octal number system, decimal number system, hexadecimal number system, and the last one is number base conversion, which is decimal to octal, octal to decimal, decimal to binary, binary to decimal. Likewise, can convert one base to another base. So these are all the content we have to discuss in the unit 1. Okay, go to next slide. Analog and digital signals. So what is analog and digital signal? So this is a type of electronic signals. What is in analog? Analog is a type of electronic signals are time varying, because here you see that physical quantities or signals may vary continuously over a specified range, because a signal is high to low, that is a time varying. This signal, the electronic signals are time varying. Sometimes the signals are varying high, then again it is goes to base value. So that's why the analog signals are high and low, that is a maximum and minimum and maximum values which is either positive or negative. That means the ranges time varying is minimum and maximum values which is either positive or negative. That is periodically the values are changed, or also called the analog signals work on continuous data. What is its work on continuous data? Then next point, the accuracy of the analog signal is not high when compared to the digital signal. Okay, the accuracy, that is the accuracy of the analog signal, that is the value can be transferred. Suppose if you have to transfer one the informations to one system to another system, the accuracy of the transmission is not good for the analog signal compared with the digital signal. Digital signal is more high for accuracy. Okay, the only advantage for this analog signal is it helps you to measure natural or physical values. Okay, natural or physical values, that is the main advantage of analog signal. You see that this is analog signal for varying and varying for time varying, that is minimum and maximum values which is either positive or negative. This is known as analog signal. Next, what is digital system? Already I told you a digital system is a programmable machine that is process a binary data, that's process only a binary data. Okay, the computers understand only binary data. So in the digital signals it denoted as a continuous signal. Digital signals are also called a continuous signal, but the difference between analog and digital signals are it can be processed and transmitted better compared analog signal. Whereas in analog signal, the signal is not high accuracy, but in digital signal it is processed and transmitted better for transmitting and processed better way for choosing digital signals. Because of it is a versatile, so it is widely used. Okay, so these are all the points for analog and digital signals. This is for basic one. The analog signals are work the only way for measuring natural or physical values, but in digital signals it is better processed and transmitted over discrete values, that is zeros or one. Okay, next, binary digital signal. In binary, values are represented only zeros or one, that is also known as digits. Digits means is a single digits like 0 and 1, so both are digits. So these digits are represent binary values. So only two levels, that is a two binary values. Otherwise the binary values are called words, that is symbols, false or true, that means F for false and T for true. Sometimes it is called low and high, low for L, then high for H, capital letter H. Or in the another words, on off. So on for 1, off for 0. Okay, so in the above figure, the binary digital signal which is low to high, that is sorry, high to low, then again it goes high, that is logic 0 for it is a bottom of the value is 0, then undefined for middle value, then logic 1 for uh, top of the value, that is signal which is starting from high to low, then again it is high to low, high to low, high to 0, 1 0 1 0 1 0. Likewise the digital signals are transfer the information. Okay, so this is known as binary digital signal. Go to next. Next topic is number system. So an integers are normally written using positional number system. because each digit represents coefficient in power series. So here one formula is an n for number system. A of n minus 1, then r to the power of n minus 1 plus then again incremented for second digit, then third digit up to a2 r power 2, then a1 r power 1, then plus a0, where n is a number of digits. It is n is a number of digits, r is the radix or base of the number, a is the coefficient. Okay, this is for normally called as integer numbers. Okay, it's not a fractional number, it's only for integer numbers. Integer numbers is represented capital letter N. Okay, in a digital system there are four types of number systems for often using digital circuits. They are decimal, first one is decimal number system, binary number system, octal number system, then last one is hexadecimal number system. For the decimal number system, it has a base that is r equal to 10. For example, in the decimal number system, the range of decimal number is 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, totally 10 numbers. That's why the base is taken on r equal to 10 and the coefficient is a. Likewise, the binary number system is only for two digits, that's why the base of the number is r equal to 2 and the coefficient is same for a. Then octal number system, the base of the number is 8 because the range of the number is 0 to 7, only 8 digits, that is 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7 only. It could not came 8 and 9. Then after that 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay, this is known as octal number system. Then hexadecimal number system is a base 16. It has 16 numbers. It represents the starting number is 0 to 9. After that A for 10, B for 11, C for 12, D for 13, E for 14, F for 15. This is the range of hexadecimal number system. Okay, so these four types of number system for often used any digital circuits. Okay, first, the next we go to one example, that is 97142 is a number, is a integer number which is represents units, tens, hundreds, thousand and ten thousands. For units, only two units, that is 2 into 10 power 0. 10 power 0 is 1, that is a unit, it calculated as unit. 10 power 1 is 10, so 10 into 4 is 40. Likewise 10 power 2 is hundreds, so only is 100 is there. Then 10 power 3 is thousands, so 7 into 1000 is a 7000. Then 10 power 4 is 10,000, so 9 into 10,000, that is a 9,000, so 9, so 90,000, so 90,000, so 97,142. This is known as a integer number system, which is separate weights are there for like calculated units, tens, hundreds, thousands and ten thousands. Okay. This is called a number system. Okay, next, decimal number system. So base of the decimal number system is only 10 because the range of the number is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 numbers. So the base r equal to 10. So 10 digits. The next, digit position, integer and a fraction. Okay, first part is a integer, that is a left hand side. Then right hand side is a fractional part. After that dot, that is known as a fractional part. For each digit has a weight, that is a base position. For like first two for units, that is 1, then second 1 for tens, then 5 for hundreds, so 512. Then after that the fractional will be calculated as -1 and -2, that is 10 power minus 1 is 1, 10 power minus 2 is 0.01, 10 power minus 3 is 0.001. Okay, likewise the minus will be calculated, that is the fractional numbers. Then magnitude. For sum of digits, we can sum it for get the result of 512. For sum it 500 plus 10 is 510, 510 plus 2 is 512. Likewise 0.7 plus 0.04 is that is 7 point, that is 74, 0.74. That is the formal notation for 512.74 is a decimal number, that because of the base indicating 10, so you can easily identify this number is decimal number system. Okay. Okay, thank you students. This is for introduction class. Just I explain only a decimal system, then analog versus digital signals. Then what are the number systems are there in number systems are supported in digital circuits. First only I explain digital number system. Remainings are explain. We will see next class. Okay. Keep on watching videos.